Okay, we have here today another integral from the MIT integration bee from 2006. This one here was problem number 2. We have the integral of x to the minus 1/2 over 1 plus x to the 1/3 dx. Okay, what I usually like to try in a case like this is I'm first looking for a u substitute. It should be nice if I could just substitute the denominator and get back something like the numerator. But if we differentiate this denominator, we get back something like x to the minus 2/3. So it's not a real good match for what we have in the numerator. We also could try to factor it, but I don't think that's going to be any better. So what I like to do in a case like this is actually I'm going to try to rewrite it. And what I want to do is get a common denominator between the exponents. So for example, for this numerator, I can write this as x to the minus 3 over 6. And then the denominator, what I can do for this one, getting the common denominator of 6, I can write this as x to the 2 over 6. And then from here, what I want to do is make a u substitution, but I'm going to do it not for x to the 2/6. I'm going to do my substitution for x to the 1/6. The nice thing about doing it this way is when we substitute, we end up getting all whole number exponents and everything. So that makes it a little easier to deal with. So I'll take the derivative. And actually, before I take the derivative here, I think I'll just take the 6th power on each side. So I can isolate x by taking everything to the 6th power. And so we get x equals u to the 6th. And now we'll take a derivative. And so for our dx value, we just get 6 u to the 5 du. And before we substitute, one other thing I can do down here, just to make it clear, like for x to the 2/6, that's going to be this squared. So x to the 2/6 is going to be the same thing as u squared. And for this, like x to the 3 over 6 is going to be u cubed. Or if I do x to the minus 3 over 6, this is going to be u to the minus 3. So now we'll just go ahead and we'll do the substitution. So again, here this is going to be u minus 3. Here we're going to have 1 plus u squared. And our dx is this thing. So this is just going to be 6 u to the 5 du. So for the 6, we'll just bring that up front and we'll rewrite over here. So we'll have 6 and then u to the 5th times u to the minus 3. I can write this as u squared. And this is going to be all over 1 plus u squared du. And now for this here, I think what I want to do, let's just make it easy. And if I add 1, then this whole integral becomes 1. But so I don't change it, I'll subtract 1. So then we'll just split this up into 2 integrals. So the first one is going to be this integral of just 1 du. The second one, I'll distribute the 6 to the minus 1. And we'll have minus 6, and this is just going to become du over 1 plus u squared. So now integrating the first one, integral of 1 is just going to give me 6 times u here, minus 6, and then here this is just our formula for arctan. So we're going to get here, this is just going to be arctan of u. So in order to finish, we just need to back substitute right here with our u value. So what we're going to get is, this is going to become 6 times, I can write this as the 6th root of x, minus 6 arctan of the same u value, which is just right as the 6th root of x. We'll add a plus c on there, and that's going to be it. Okay, so there you have it. Good problem from MIT 2006. Thanks everyone for watching. Have a good day.